So for today, it's mostly a review day, except we do a few more changes to the graphs. Like instead of just saying, here's cosine, we were getting a little more intense about there's a 4 here instead of just theta. All right, so I need to teach you a few things. There is a number in front of every one of them. It's usually just a 1. And then there can be a number on the inside here. And then there can be a number as a shift, like over, and that's called a phase shift, like the blue number. And then there can be a number at the very end I'm going to make green, like +2. This is A, this is B, this is C, and this is D. Those are the 4 possible changes you can make to a graph. All right, so please write this down, and I'll tell you what each one does. Just copy this down. This is the amplitude. And basically, the amplitude is, remember on the wave, here's cosine's graph. Amplitude is how high up you're going. And normal is 1. So that 1 in the front, that's just normal amplitude. This B right here, what I want you to write about that is that the period is 2 pi divided by whatever that number is. So whatever that number is right here, you divide by that. So if the graph had gone to 2 pi, we divide by that 4 that's right there. We go divided by 4. All right, the C is what's called the phase shift. And we will never have a number here and here at the same time. It just gets too complicated, but we might do either. We could do a phase shift or we could do a period change. And the last thing we can do is this is just up and down. You move the whole graph up or down. All right, so imagine that, I'll leave these notes up for just a second. Imagine I gave you this one, y equals 2 sine of 3 theta minus 5. Tell me what got different. I got a 2, a 3, and a 5, and they do different things. Turf, what does that 2 do? Good. And so instead of going up to 1, now it goes up to 2. And instead of going down to -1, it would go down to -2. Okay. How about this 3? It changes the period. Because the period is 2 pi over b, see? So my period is no longer 2 pi on this one. My period would be 2 pi is what they start at, but you divide by whatever that number is, 2 pi over 3. And so my period is my numbering across the x-axis. We'll get changed for that. And the last thing we could do is move this down 5. That making sense that that's what those changes are? Okay. So let's give you a really simple one. Everybody just graph sign. If you forgot, I'll remind you, you label these 4 spots 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. I know, it's 2 pi. And then sine starts at 0, 0. And it quickly peaks. Like right away, it hits its peak. See if you can draw the rest of it. That includes labeling this and how far down it goes. I'm going to pause for a second and let you give that a shot. So, if you haven't already, which I suspect many of you haven't, please talk through what numbers go here and here and make sure your graph looks the same as the kid next to you. These 2 rows, play straight across. Dominic, you're going to go diagonal. The girl in the back there, these 2, straight across. You're gonna turn and compare with the guys behind you.
One negative.
You two, you three. All right, it peaked right away, and the next thing it does is goes back down to 0, and then it goes down to its lowest spot, and then it comes back up to complete one, what's that called? Period. Good. So when I ask what's the period, I'm going to ask 4 questions. Period, amplitude, phase shift, and an okay answer is to just say there isn't one. I can't remember the last one. Okay, I think there's one more question they're going to ask on the worksheet, but we'll get to that when we get to the worksheet. So what is the period? Well, it's 2 pi over b. There's no b term, though. So isn't there just a 1 there? So isn't the period just 2 pi? Does that make sense to you? It's 2 pi divided by whatever number's here, and there's just a 1 there, so... The amplitude is whatever number's in front. Well, there's another number, that must be a 1 there. Amplitude's 1. Phase shift. Did this thing get shifted to the right? No, there was nothing here. If there was something in there, like a minus something, then we would have shifted it to the right or left if it's a plus. But there wasn't anything, so you just say no. There was no phase shift. All right, should be a 1 here and a negative 1 here. And now just let me show you, on this same graph, what if there had been a 5 in the front? It's so easy. Just tweak your graph a little bit. Throw a 5 in there and change one little thing. That's 5 and that's 5. Well, negative 5 actually down here, but see, now I'm not going to make you redraw this thing 5 times as high. If I did, it would look something like that if I actually had you do it 5 times as high, but I don't make you do that. I just make you number it this way. Okay. But would that change my amplitude? Yeah, my amplitude would be 5. All right, now what if I put a 4 in there? Now we're going to have to change the graph totally? No. Nope. It's actually super easy. The period is now 2 pi over 4, and all you got to do is divide everything by 4. But to avoid having to have a fraction divided by 4 on all of these, and then it's like a fraction over a whole number, that looks really weird. Instead of dividing everything by 4, we can multiply everything by 1/4. So that's 4 pi over 8. If I multiply everything by 1/4 like this, I think you're going to notice a cool pattern. This will be 1 pi over 8. This will be 2 pi over 8. This will be 3 pi over 8. You see what I'm doing here? You just get to count by that nice little 1 pi over 8. So then this must be 4 pi over 8. I'm aware that they reduce, but I like that I can count them up so easy. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. All because I put a 4 there, right there. And I don't want to try to add a phase shift to this because it's going to make it just so complicated, and it's already messy enough. But a phase shift would have moved it right or left. So that's probably the next thing we should do. So everybody, now graph regular cosine. Just regular cosine. It's very similar. These 4 marks are labeled exactly the same. What it goes up and down to is exactly the same. It's just that cosine starts at its peak, and it goes down from there. And remember, it's like a valley. It's like Breckenridge. I'm going to pause for a second while you guys graph cosine and label it with all the x and the y-axis labels. Okay, let's see if you remembered what this thing looks like. I do it in 4 parts because to me the curves get too confusing otherwise. So there, I got to the lowest spot, and now if I do each little curve, it's not that bad. Then it goes back up to 0. And the last part is this little curve where it ends at its peak again. This should have been 2 pi, and I like to count 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. That way, if we move it to the right, which we're going to, it'll be easy to label this last spot. So those of you that insist on doing it some other way, good luck figuring out what number's right there. But if you do it the way I did it, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, it'll be easy. Okay, now I just said we're going to shift it. So let's do that. Everybody put a parenthesis around here. Oh, wait, I also forgot to label this as 1 and -1. Okay. And let's move this thing minus pi over 2. Now, is minus, when it's on the inside, right or left? It's right. So this is called a P shift, phase shift. And it is directional, so you have to say right. If it had been left, that would have been a plus. Phase shift right, pi over 2. I think the easiest way to say this is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 is where it's going to shift to. And I think you should just go like this. It goes to the right that far. Because look, that's what pi over 2 is. It's that far. Okay, I'm going to erase this, though, and I'm going to take each of the main spots on this graph, which I would determine to be this, 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 and this, and I'm going to move them all over 1 mark. And now my new marks I will make blue are here, 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 and there. And now I just have to connect those dots. There. The new graph is the blue one. And I think if you make those little arrows, it really, really, really helps. At least it helps me. If you try to freehand that, it could get bad. So I'm going to put in my little arrows one more time in black. These little arrows here that are telling you how far over to move, I think those are really smart. Okay. The most common mistake on the test is going to be kids are going to move it over, but they'll leave this spot unnamed. Not even really because they don't know what it is, but because they don't even think that they have to label it. But if you move the graph over something that's not labeled, you can't graph above something that's not labeled. So you have to have this number here. And again, if you count it up, 1, 2, 3, 4, 5 pi over 2, it's not that bad. Okay, now, did that change the period? I gave you a little formula for period. It's 2 pi over what? B. Is this B? No. B would be if there was a number in front of that. If there was like a 7 here or something. But there isn't. If there's no number there, then what number is there? 1. So this is really, period is 2 pi over 1, which is just 2 pi. So this does not have a changed period. It still takes the same amount of time, so to speak, to complete a whole cycle. 4 marks. Okay. One last thing. If, I'm not going to actually do it, but if I put a negative in front of this whole thing, do you get the whole thing would flip upside down? I'm not asking you to do it because this one's already messy enough, but do you get that then it would go like this? It'd be that black one. Because what the lowest spot becomes the highest spot. See what I mean? It just flipped. If you put a negative in the front, that's what happens. All right, another really common mistake is About the amplitude. Amplitudes can't be negative. Try to remember that your amplitude is a whole number. So even if I made this negative here, my amplitude is still 1. There's no other number in the front than 1. So my amplitude would be 1, and negatives don't count. So the amplitude for this is 1. All right, so let me give you one more. Y equals negative sine of theta minus 4. I'd like you to just answer these questions. What's the amplitude? What's the period? What's the phase shift? Don't even graph it. Just tell me what's the amplitude, what's the period, and what's the phase shift. These are kind of trick questions. In a second, I'm going to ask you to talk with your friend right next to you and then see if they and you have different answers, which is very possible. And then try to decide who's right. Those 3 little answers: amplitude, period, phase shift. Please compare with the kid next to you. See what you think.
Yeah, and then actually for amplitude 1 because you can't do negative
2 pi
Yeah.
negative 4.
Okay, amplitude is 1. I expect a few kids to say negative 1 because they didn't hear that really important thing that amplitudes can't be negative. All right, but otherwise there's no other number there, right? So it's 1. Period. Well, I could just write 2 pi over b would be a great way to start, but then I gotta know what's b. And trick question, there was no b there, so there's only a 1 there, so therefore it's 2 pi over 1, which is just 2 pi. What's that for? That 4 is not the b term. That 4 is a move up or down. And that is not a phase shift. That's just moving the whole graph up or down. A phase shift would have to be inside here in a parentheses. So I know, trick question. There was no phase shift. Let me show you the difference. If I had said negative sine of theta minus, it would be something like pi over 4 or something like in radians. See, this is the phase shift part. That is not. Okay? So, amplitude was 1, period was 2 pi, and the phase shift, it didn't have 1. Now, I want to graph this one. So, if you know what regular sine looks like, then you can make that first. That's what I recommend you do on all of these graphs. Graph pure normal sine, and then go, okay, now I got to flip it, and now I got to move it this way. So graph pure normal, just sine. Okay, you can watch me do this fast. 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. That's 1, that's negative 1. Here's normal sine coming at you. There. Okay, now I want to fix that. It hits its peak right away. There we go. Okay, so there's sine. Now I got to do this negative. That makes the whole thing flip over. And it goes like that. Do you get that the black one's gone now? That was the original parent one. And now we've got the blue one. Okay, now I got to move the whole thing down 4. So I like to draw these arrows. And how far down do I go? Well, if that's 1, I got to do 4 like that. You don't have to draw 4 arrow tips like I did, but you need to go down. If this is 1, you got to go down 4 times that far. Same with this. 1, 2, 3, 4. My new point's like there. Bring this one down. 1, 2, 3, 4. and my new point can be right there. Bring this down 1, 2, 3, 4. And my new point can be right there. Make them all blue, I guess. And then this one comes down 4. My new point's right there. And so there's my new wave. That make sense to you? Okay, then can you answer these questions? What's the amplitude? What's the period? Was there a phase shift? If so, you got to know how to say it. And again, our original graph here. Just looking at it, amplitude is how high up and down it goes. It's going up and down 1. And its period gets over with in the same amount of time as normal. It's still 2 pi. And the phase shift, that shift I did, that was not a phase shift. There is none. Okay. I feel like you're getting it now. I'm going to give you one that's based on cosine and has 3 changes. If you can do this, then I will feel like you are completely ready and we can spend the whole rest of the time on homework. So try really hard on this one last one. I'm just going to make it 4 cosine of 3 theta and move it up 1. Always start by graphing regular cosine. It always looks the same to start with. Then make your 3 changes to it. I'll pause while I give that a shot. Okay, in case you forgot, cosine is the one that looks like a big valley. So I'm going to start here. And it goes down to its lowest low. Right? Some kids that are like super careful about this will draw better lines than me. And one of the ways you can do it is by putting dots where it kind of like ends up. And then being really good artistically about making those curves just right. I'm going to allow kids that are not as artistic like me to be okay on the test if your graph isn't completely smooth and perfect. There it is. I bet you a lot of yours was better than that. This went 1 and -1, but then quickly changes to a 4 and a -4 because of that 4 right there. And then this was 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. And I can go now and put a 3 in, but no, I don't multiply everything by 3. I multiply everything by 1/3. And if you get this pattern, you're going to go, oh, so it's pi over 6s, and 2 pi over 6, and 3 pi over 6, and 4 pi over 6. And I know they're reduced, but boy, it's nice and clean this way. Those are your 4 numbers. Raise your hand if you had the numbering right across the bottom there. Okay, good. Looks like most people are getting that. And then the last thing is this +1. And that means the whole thing moves up 1. How much is 1? I just moved up what would be like a whole mark. That would be like moving up 4. I hope you didn't do that. Because remember, 4 is how big a mark is now. So I need to move up only 1. So I move up only a little bit, like 1/4 as far. So each little spot that's the key spots, they move up 1, not 4. And so my new graph can be like there, 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 and there. And there we go. It's the black one. It's been moved up 1. Okay, last thing. Amplitude, it's not 1. Period, it's not 2 pi. And phase shift, I'm not telling. Chrissy, what's the amplitude? 4. 4. What's the period? 2 pi over 3, because it's 2 pi over b, and that's what 3 is. Nice job. And Rissy, just finish it off. The phase shift? None. But what about this? That's not a phase shift. Phase shifts are on the inside. No. I can't write no, apparently. No. Or not. Or does not exist. There is no phase shift on this one. All right, cool. So, on your homework, you're only doing 3 problems because on each problem you also have to answer what's the phase shift, what's the amplitude, you gotta kind of, they're detailed. And literally, I'm cutting this down to like 1/5 as big as it could be because I don't think you'd do it. But I think you really would do the 3 problems I assigned. In the title of it, it says problems 1, 5, and 6. Those are the 3 I want you to do. Just do those really thoroughly and well. And if you do, then I think you've practiced enough. Would you please read me number 1, Bodie?
Y equals -4 cos,
Cosine.
or cosine, and then parentheses 2x.
All right. Looks like they made 3 changes to cosine. So just start by doing regular cosine. Always just start with the normal one. It's so much easier. There's regular cosine. This negative is going to make the whole graph reflect up and down, vertically reflect. That means it basically flips. So it's kind of like that. This 4 is just going to need to change some numbering. I'm not going to make you actually draw it 4 times as tall. It would go off the page. So just change the correct numbering. Put the 4 in the right spot. And the last thing you'll have to do is your period used to be 2 pi here. You either have to divide by 2 on everything, which is a pain in the butt, or multiply all the numbers by 1/2. That's what that does, is it changes all your numbers. Multiply them all by 1/2 and get your new numbers. All right, that's all I have for you for today.